Hello students, today we are going to learn about complex numbers. This is one of the most important chapter which is included in our half-yearly syllabus. We have to learn it properly. At first, there is an introduction given for complex numbers and imaginary numbers. You just try to read this and try to understand. I'm not going to read this all. So before learning complex numbers, you have to know what are imaginary numbers. Imaginary numbers we have learned before. It is denoted by the small letter I, and we can have this by solving this quadratic equation x square plus 1 equal to 0. We know how to solve this one. X square is equal to minus 1, and then we'll have x equal to plus minus root over of minus 1. This I is equal to root over of minus 1. Okay, as we have seen that solving x square plus 1 equal to 0, we had the imaginary number as its roots. Same way, this is an application. Okay, if we solve this one, this quadratic equation will have two roots, and you can see there is an I along with them. So these are complex numbers. Actually, these are complex numbers. Okay, so here goes the definition of complex number. Of a complex number, you have to know the definition. A number of the form a plus ib, where a and b are real numbers and I equal to root over of minus 1, then it is called a complex number. This spelling is wrong, this is the correct one. Okay, and usually a complex number is denoted by Z. Okay, Z is equal to, it is written like this: Z is equal to a plus ib, a comma b belongs to R, and I equal to square root of minus 1 is a complex number. Now if we want to represent it as a set of complex numbers, so it is represented by this capital letter C, and it is a plus C equal to a plus ib, such that a comma b belongs to R and I equal to square root of minus 1. This Z equal to a plus ib, it has a real part and an imaginary part. Okay, the real part is a and the imaginary part is b. A real part is written by RE Z, and imaginary part is written as I am Z. You can also represent a complex number as an ordered pair. Okay, you can also represent as an ordered complex number as an ordered pair. How? Since Z is equal to a plus ib, for Z equal to a plus ib, the ordered pair is a comma b. For Z equal to p plus iq, the ordered pair will be p comma q. That means pq. Okay, there are different operations of complex number. The first one is the addition. That means adding two complex numbers. That generally we take Z is equal to a plus ib as the general one. a plus ib as the general form of a complex number. Now if you take it as z1 and z2, we write it as z1 equal to a1 plus ib1 and z2 equal to a2 plus ib2. On adding, what we have? We have another complex number. Okay, on addition we can see that the real part is added together, and taking I common, the imaginary number common, we have the imaginary part b1 plus b2, where a equal to a1 plus a2 and b equal to b1 plus b2. This is also a complex number. So addition of two complex numbers gives us another complex number. So as an ordered pair, you can write it as a comma b, where the real part and the imaginary part is. It is given the sum of two complex numbers is also a complex number. Coming to the subtraction of complex number. Same way, two complex numbers, when you are subtracting, we have the real part, imaginary part, and again it is also a complex number. So addition and subtraction of two complex numbers gives us another complex number. Similarly, we can represent it as ordered pair also, like this. Then we have multiplication. Multiplication of two complex numbers. Same way, when you multiply, you have another complex number p plus iq, where this is equal to p, this is the real part and this is the imaginary part. So the product of two complex numbers is also a complex number. This is simple addition, subtraction and multiplication. You can represent it as ordered pair also. Then here comes the division of two complex numbers. Same way, if we do, what we'll have? We'll have the complex number as alpha plus I beta. This is the real part and this is the imaginary part. So we again have a complex number. That means whatever it is, we can conclude that addition, subtraction, multiplication and division of two complex numbers gives us a complex number. While we have gone through the definition, we have seen that complex numbers are of the form a plus ib, where a and b are real numbers, and it is expressed by the small letter z equal to a plus I b in the real part and the imaginary part. Okay, r z is the real part, I m z is the imaginary part. Now one thing we have to remember, if in a plus ib this a becomes 0, then what is left is what? ib. Yes, this ib is known as pure imaginary number. Why pure imaginary number? Because there is no real number associated with it. So some examples are given here. Minus root over of minus 6, root over of minus 9, this is equal to what? 3i. So whenever there is an I with it, it is a pure imaginary number. And remember, I alone is known as the imaginary unit. Okay. So here, this one is important. We have got before that I is equal to square root of minus 1. Now, you can see we have some standard values. Okay, the standard values are, already we had I is equal to root over of minus 1. When you square on both sides, you have what? I square is equal to minus 1. Likewise, we will have I cube equal to minus I to the power 4 equal to 1, I to the power 5 equal to I, I to the power 6 equal to minus 1, I to the power 7 equal to minus I to the power 8 equal to 1, I to the power 9 equal to I, like this till I to the power 11 we have done. So it is minus I. You can see it is in a pattern. Okay, minus 1 minus I, 1 I, okay, then minus 1 minus I, 1 I, minus 1 minus I. So alternatively they are changing their signs. Okay, they are changing their signs. Now how they are found out, I'll show you now. You can see here I equal to this one, already did, I square equal to minus 1. Now I cube, what we can write, I square into I. Instead of I square, what we can write, minus 1 into I is equal to what, minus I. Okay, then I to the power 4, I to the power 4 we can make what, I square square. So I square we know, minus 1 square equal to what, 1. I to the power 5, what we can write, I to the power 4 will bring it to the known value. What we know the values, I square equal to minus 1 we know. Okay, so I to the power 4 into I to the power 4 we can make I square square into I. So this one, I square means what, minus 1 whole square means what, I. Likewise I to the power 6 we can do, I to the power 6 we can make I square cube. Okay, then I to the power 7 minus I, and I to the power 8 we can make I to the power 8 we can make I square to the power 4. I square means minus 1 to the power 4 is 1. So please do this one as homework, do by yourself, make it and show me. Now as I told you, it is following a pattern, 1 minus I, 1 I, minus 1 minus I, 1 I, minus 1 minus I, then 1 I, like that will go, then again minus 1 minus I. Okay, now if you look at here, we'll find that wherever, see, there is 2, 4, 6, 8, 10, we are having what, all 1. Wherever there are even numbers, wherever you can see, wherever we have even numbers, okay, we are getting 1 minus 1, 1 minus 1, like that. Okay, and wherever we are getting odd numbers, we are getting minus I, minus I, minus I. So wherever they are even, we are getting 1 minus 1 or 1 odd numbers. That means if you take it as I to the power n, and if it is odd, it is either I or minus I. Okay, so we have seen the pattern and it follows a sequence, and we have found out a formula for this. What is the formula? Okay, now the formula I will show you now. This is itself the formula. Okay, whenever there is a multiple of 4, it is always 1. I to the power 4, 1. Okay, I to the power 8, 1, 1. Then I to the power 12, it will be 1, like that. I to the power 4 plus 1, it is always I. That means a multiple of 4, then plus 1. So it will start with what? I to the power 5, it will be I. Then I to the power 9, I. Then I to the power 13 will be I. Then twice, that means adding more, 2. So 6 is that one. Multiple of 4 plus 1, multiple of 4 plus 2, that is I to the power 6 minus 1. Okay, then I to the power, it will be 10 minus 1, then next it will be I to the power 14, it will be minus 1, like that. Next one, which is not given in the book, but still I to the power 4 and minus 1, so the less than the multiple of 4, so it will start with what? I to the power 3. I square we know it is minus 1, will not relate with multiple of 4. Okay, we'll start with from here. So I to the power 4 minus 1 is I to the power 3, it is minus I. Then next one it will be what? Multiple of 4 is 8, minus 1 is what? 7, minus I, likewise. Okay, then 12 is there, minus 1 is what? 11, minus I. Okay, did you get this? Please do remember this one. Another important part is if I to the power n, where n is negative. The previous case n was positive, here n is negative. Look at here, I to the power minus 1, I to the power minus 2, I to the power minus 3, and I to the power minus 4. When it is I to the power minus 1, it is minus I to the power minus 2, it is minus 1. Again it is following the same sequence, not this time minus I minus 1, I1, again minus I minus 1, again I1. Okay, it is also following a sequence, but before that we'll see how it is, how we have found this all. We'll see, check this one, then we'll check that one, then we'll check the pattern. See this one, I to the power minus 1, I to the power minus 1, what we can write? I by 1 by I, because this is law of indices, it will come down. This means what we have done here, we know we have done for rationalizing the denominator there. Here also we'll learn, we'll like rationalizing it, so we'll not keep any imaginary number on the denominator. So what we have to do, we know if you can multiply another I to it, it will become I square, so it will become minus 1 and there will be no denominator. So what we have done, the numerator and denominator we have multiplied both with I. So here we are getting I and here we are getting I square. So that means what? I by minus 1 equal to minus I. Yes. Likewise, I to the power minus 2. Now I to the power minus 2, what we can write? I to the power minus 1 whole square. I to the power minus 1, we know it is what? Minus I. So likewise, okay, minus will go, I square equal to this one. Okay, then I to the power 3, I to the power minus 3, I to the power minus 3, what we can write? 1 by I to the power 3. Again I to the power 3, we know I to the power, the value of I to the power 3 is what? Minus I. So again we have to rationalize, so we are multiplying both numerator and denominator as what? I. So we are getting this one as plus I, then again plus 1, and then I, this one. Likewise, I to the power minus 4 is what? Like that we are doing it. Okay, if you want to take a screenshot, you can take it. Okay, now if you see here also they are following a pattern like minus I minus 1, I 1, minus I minus 1. See, minus I minus 1, I 1, then minus I minus 1, and again I 1. We'll do it. Okay, we'll do it in at home please. Okay, and that means it is following a pattern. So the pattern is, whenever there is I to the power, it is a multiple of 4, negative, of course it is 1. 4n plus 1 minus, it is minus I, then 4n plus 2 and there is a minus, so minus 1, and this one minus 4n minus 1 is I. This one you have to memorize. Okay, if you want to take a screenshot, you can take it. This is for n negative, if n is negative. If n is negative, we will get this one. Okay, one very important note you have to remember, that we know this one, root over of 3 into root over of 5 is equal to what? Root over of 3 into 5 is root over of 15. Okay, then again root over of minus 3 into root over of 5, we can write what? Root over minus 3 into 5. So minus 3 into 5 we can make it 15, and minus we can take out. Okay, we can do it this way also. This is better. Instead of coming from here, here we have 1 root over minus 1, so we are taking it out. So root over minus 1 into root 3 into root 5. Okay, root 3 into root 5 we can put it together as we have done here, and root over minus 1 means what? This root over minus 1 is what? I. So it is what? I root 15. Okay, now look at here. Now here if both were positive, we can write like this. Okay, we can do this one. If both are, one is negative, we can do this way. If both are negative, what will happen? If both are negative, we can put like this. Yes, which is not true. It is wrong. You cannot write like this. So when both are negative, you cannot make it positive here. Okay, because they are imaginary numbers, you cannot make it a real number. Okay, if you multiply two imaginary numbers, that means here imaginary numbers, you cannot make it. Okay, so although we can make it a real number, okay, but it is not like this. How to do? You have to follow always this process. Okay, this note, this is very important. This is very important. Okay, this part is very important. Root over minus 3 into root over minus 5, you have to take out root from both. Root over minus 1 from both. From root 3 we take out this one, and from root 5 also we'll take out. So this means what? I, and this means also I. We'll separate these two. We'll have I into I square, and 3 into 5 as usual we have done there. 15 we can make, and I square means, you know, it is what? I square means what? Minus 1. So it is a real number. Okay, thank you all.